my name's Kelsey, and today I'm going to be showing you some tips and tricks for how to use the TI-84 calculator. So to start off, we're going to be doing something that's relatively simple, and you can do it one of two ways, but what it is this problem here. It's going to be the integral from 1 to 3 of cosine x squared dx. And so one of the first ways to do this problem is by clicking this y equals button right here. And what you'll get on your screen is it says plot 1, plot 2, plot 3, and I'll have like all of these y1, y2, y3, y4, and y5. So what we're going to do is we're going to plug in the equation cosine x squared. So I'm just hitting cosine and then x squared. And then right here I'm hitting the graph button so I can see it. And so now what I'm going to do is I'm going to hit second and trace, which is going to be this calc button right here. And it comes up with all of these options. So I'm going to scroll down to the 7th option, which is the integral one. And it's going to ask me what the lower limit is. And according to this, the lower limit is going to be 1. So I'm just going to hit 1, then enter. And then it's going to ask me for the upper limit, which is 3. So I just click 3. And enter. And then it kind of did that cool highlighting thing, and it gave me the value, which is negative 0.2016607. Now if we're back to the main screen of the calculator, there's another simple way you can do this problem. And what you do is you just hit this math button, and then you scroll down to number 9. Which is, it says f and int, which is for integration. You hit enter and you'll get this with all of the empty boxes that you're supposed to fill in. And so I'm just basically going to copy this problem down into my calculator. So the lower limit is 1, the upper limit is 3, and then in here goes cosine x squared. And then since we're doing this in respect to x, I have to do dx. Then I just hit enter. And I get the same answer that I got before, which is negative 0.2016606,802. So either way works, and they're both pretty simple. So another thing that the calculator is really handy for is doing a problem like this, where they give you an integration problem, but there's absolute value bars, which are normally a pain, because what we would have to do is set this equal to 0 and find all of the zeros on this integral. And that's just really difficult and not fun, and then we'd have to manually plug them back in and like separate it, and it's just a lot of time that you could be spending doing better things. So what the calculator does for us is if we go to that math button again and then scroll down to the 9th option and click enter, which is what it does is it gives us this again, and then the lower limit is 0, upper limit is 5. And then in order to get these absolute value bars in, what we're going to do is we're going to hit that math button again, then the little right arrow over to the num, I'm not really sure what that stands for thing, and then the first option is ABS, which is for absolute value, and you just click enter. And then I'm plugging in e to the cosine x minus 4. And an important thing is just to make sure you like keep the parentheses together. That's just a common mistake people have whenever they're using a calculator. And then dx, because it's in respect to x, which you can see here. And then just click enter. And then it gives you the answer, which is 14.81657,174. So another type of problem that it's likely to see on a test or something would be finding the area between two curves. And in order to do that on the calculator, what we do is we first go to that y equals button again, and then we plug in the two equations. So for this problem, it's going to be sine x squared, and that's going to be my y1. And then x to the 4th is my y2. And since we're looking for area and not signed area, what we can do is instead of trying to figure out which one's upper and which one's lower, we can just take the absolute value of the difference between these two functions and then integrate from 0 to 1. So what that's going to look like is So I'm going to go to so now that we're back at the main window, what I'm going to do is set up the integral. So I hit that math button again and I'm scrolling down to 9. Enter from 0 to 1. And now I'm going to do the absolute value. So math over to num and then abs. And then instead of typing out this, what I'm going to do is hit the vars button, which is right here. And then I do function and then y2 minus vars, y vars, function, y1. Then I'm doing this all in respect to x, so I'm just going to do the little dx. And it may take a second to load because it's just processing the information. And then I got an answer, which is 0.1197976662. So if I want to store a value or find a point of intersection, what I do is if I graph, I have two random functions here, and now I click second trace, and then go to intersect, and then move where I want it to be on the first curve, and then the second curve, and then you just click a guess. Then it gives me the point of intersection, and I just wrote that down over here. It's 0.936333659. And now I'm going to go back to the regular window. I'm going to type out 0.936333659, and then I'm going to click the STO button, and then pick a variable. I'm just going to do V, so I'm going to click alpha, and then that V button, and then it's going to give me that back. Now, whenever I use that V variable and click enter, it's just stored as that value. So now if I wanted to integrate, I could hit math and then go down to integration. And then let's just say I wanted this to be the lower limit, I could just type in V and then whatever number, and then whatever the equation is, and then in respect to x. So since you're using a calculator, the main mistake that people make is just plugging it in wrong, since the calculator is doing the majority of the math for you. So just make sure, especially your usage of parentheses is on par when you're plugging it into the calculator, because that's where most people make mistakes. Thank you for watching. I hope you learned something today.